Hey students, Miss Slyman here. Welcome back from spring break. I'm going to be talking to you about graphs of trig applications. So this is basically continuing what we were doing last unit and now putting it with some application. So we have a rabbit population being modeled in thousands of rabbits in a northern region of southern Australia. And that's funny, right? Northern region of South Australia. But of course, that is okay. All right, modeled by this equation, time is being measured in months after the 1st of January. Be nice if we knew what year that was talking about, but whatever, maybe the rabbit population is cyclical. So what is the largest rabbit population predicted by the model? Well, they're asking me, what is the max? And I know that the max is going to be my A value plus my D value, because my amplitude from the center, so if I go up from the center, then I'll have my maximum, and it's going to be the absolute value of A, actually, because my A value could be positive or negative, but the max will be the positive value going up from D. So in this situation, my equation's written in a little bit of a funny way, so I'm going to rearrange it so that it says 3 sine 30t plus 12, and now it's easier for me to see that my A value is 3, my D value is 12, so I get 15, but then I remember that my rabbit population is being modeled by thousands. So I'm going to say that the max is 15,000 rabbits. 2 B's in rabbit. Maybe. That looks funny. Okay. So how long between the times when the population reaches consecutive peaks? So they're asking me for time between maxes. Well, that's my period. And I know that the period is going to be 2 pi divided by the B value. Here the B is 30. So then my period is going to be pi over 15. And we're measuring our units here in months. So I've got pi over 15 months. And so if I think about that, that's basically going to be about 1/5 of a month as my period. That does not really make sense. Oh, it doesn't make sense because I'm measuring in degrees. So my period should actually be 360 divided by 30. And that's going to make way more sense. So my period is actually 12 months or 1 year. So notice here, our input to the sine function is degrees, but t is being measured in months. So when I take 360 degrees, divide it by 30 degrees, I'm basically canceling out the units of degrees and left with the units of t, which are going to be time, which is being measured in months. All right, sketch my graph over 24 months. So I'm going to have 2 periods, basically. I'm going to say that this unit is 3 months, 6, 9, 12. And the reason that I did that is because I like to divide my period up into fourths, because that's where I see my maxes and mins. I know that my min value is going to be 12 minus 3, so that's going to be 9. So I'm going to go put in a break here, say that this is 9. I'm going to say that this is my 12 and this is my 15. So here's my center line at D. And then I'm going up 3 and down 3 with my amplitude. I'm measuring this in thousands of rabbits. And this is being measured in months from January. So 12, that's going to be 15, 18, 21, 24. There's where I'm going to stop. It's a sine curve, and I haven't shifted. So I'm going to start at the middle. I have a positive A value, so I'm going to go up from there, back to the middle, to my minimum, back to the middle, max, middle, min, back to the middle. So here's my 2 full periods of my sine graph. All right. The longest time span for which the rabbit population is greater than 13.5, and really they should have said 1,000. So 13.5 is going to be around, let's see, half of that is going to be 2.5, 14.5 would be around there. So 13.5 is going to be around here. So the longest time period is going to be between these 2 points. Well, so now I want to use my calculator and solve that. I'm going to come into my calculator. I'm going to make sure I'm in degree mode. So document settings, degree, okay. And now I'm going to solve for 12 plus 3 sine 30 times t equals 13.5. And I want to take my t. I can see it's going to be between 0 and 6. So I can even say there. So control equals to get my such that symbol. So I'm going to say 0 less than t less than 6. And now I realize that I forgot to put in my comma to solve with respect for t. So I can see that it's 1 or 5 exactly. So I can come back and I know that those points of intersection are going to be at 1, 13.5, and this point was going to be 5, 13.5. So I wanted to know the longest time span greater than or equal to. Well, the time span is this distance. So that time span is going to be 4 months. So for 4 months out of the year, the rabbit population is greater than 13.5. Oh, that's actually the answer to D. And then E, my explanation for the behavior of the model, well, your ecosystem is only going to support so many rabbits. So your rabbit population will grow and grow and grow, and then they're going to run out of food. The predators are going to be like, hey, it's a rabbit buffet. The population decreases. Then we start making more baby rabbits. It goes up, and so on and so forth. So here we are actually looking for an explanation for the behavior of the model. So that explanation is going to be about the ecology of it and why we would expect to see something that is periodic. So we wouldn't expect that the population keeps growing forever. All right, so that's me working through this example. I would like you to try to work through this example. I'm going to write out the solutions and then you can go look at them.